Hello, welcome everyone. Welcome to my YouTube channel. My name is Aditya Maurya, currently pursuing BE in Sri Venkateshwara College of Engineering. I'm currently studying in the second semester, section debut, and my USN ID is 1VE 23 CA004. Today we'll be discussing a small topic in mathematics. So the course title is Mathematics for CSE stream and the course code is BMATS201. And the topic that I have chosen today is wave propagation by integral calculus. So let's get started with this and understand with depth of this particular topic. So first, what do we have? So we'll go through an introduction, then we'll see an equation, an explanation of the topic, and finally we'll arrive to the summary of the entire topic. I'll sum up the entire topic in the last slide of the video, which will be the summary of the video. So now, the introduction. Wave propagation is a phenomenon where disturbances or variations in a physical quantity such as pressure, displacement, or electromagnetic fields propagate through a medium. For the propagation of a wave, there must be a medium. Then, this phenomena is often described using a mathematical models, and integral calculus plays a crucial role in understanding and analyzing wave propagation. In integral calculus, wave propagation can be represented by functions that describe how a quantity changes with respect to both time and space. We have an important point here, how a quantity changes with respect to both time and space. Next, these functions often involve integrals, which are mathematical tools used to compute the accumulation of a quantity over an interval. I hope you understood the introduction part of this video. Now let's go to the equation that will give us the wave propagation. The wave equation is a fundamental equation that describes wave propagation in various physical systems such as mechanical waves, example sound waves, electromagnetic waves, example light waves, and waves on strings or membranes. So next, the one-dimensional wave equation, 1D wave equation, for example, describes the propagation of waves along a single spatial dimension, example, along a string. It can be represented or written as delta square u by delta t square is equal to c square delta square u square delta x square. I'll just rewrite this thing. Delta square u divided by delta t square is equal to c square delta square u divided by delta x square. So this is the equation of the wave propagation. Now let's see what these x, this c, and this u, this t stands for in this particular equation, where u of x comma t is the wave function representing the displacement or variation of the quantity being studied. U of x comma t is the wave function which is representing the displacement or variation of the quantity being studied. Whatever we are studying, it is representing. T is the time and x is the spatial coordinate and c is the wave speed. We all know it that c is the wave speed. So next, explanation of the equation or the wave propagation. So now the wave equation involves partial derivatives which describe how the wave function changes with respect to both time and space. Solving the wave equation typically involves techniques from partial differential equations PDES. Solving the wave equation typically involves techniques from the partial differential equations PDES, which often require integral calculus. Integral calculus comes into play when solving boundary value problems or initial value problems associated with wave propagation. Now, boundary value problems involve finding the solution to a differential equation subject to specified conditions at different points in space or time. Initial value problems involve finding the solution based on the initial conditions specified at a particular time. Integral calculus is used to integrate the differential equations that govern wave propagation, often to find the general solution or to determine specific properties of the waves, such as their amplitude, the frequency, or the energy. Integration allows us to compute quantities such as the total energy carried by the wave, the total energy carried out by the wave, the rate of energy transfer, or the displacement of particles in the medium. I hope you understood all the explanation that I just read out, that I just gave you. And then finally come to the summary part, which will sum up all of the video that I just spoke, that I just taught you. In summary, integral calculus is essential. Integral calculus is essential for understanding and analyzing wave propagation because it provides the mathematical tools needed to solve. Because it provides the mathematical tools needed to solve the differential equations governing the behavior of waves and to compute various properties associated with them. I hope you understood this. So if I were to tell to sum up the entire video, just go through the summary twice and you will understand what the entire video was about. You will understand wave propagation using integral calculus. So we used integral calculus in this. I hope you understood this thing. And yeah, thank you for watching the video. I hope you understood the entire video, and if you have some problem in understanding, please let me know. Do comment on the video, like, and do share it. Thank you.